Okay, so just for right now, what I'd like to do is go through and talk about events and talk about modifiers. So this is 2-2-4 and 2-2-5. So the general idea for, we'll cover events first. Events are really just like cheap storage. You can kind of think of it as like logging, to where you can actually like log information about something that happens in your smart contract. So this is just a good example here where we have like 2 logs that are able to be emitted as events. So we have one called log, which has a two basically parameters that can be indexed inside that log, and one is an address, which is going to be, in our case, it's the sender, and then a string, which is a message. So in this case, we're just basically able to capture the data for a specific address in this log, right? And then you can see that we have a function here that just emits that log, and it uses 2 variables. It uses the message.sender, which is the person that's sending the transaction on the Ethereum virtual machine. It's basically a global variable that just keeps track of that account address. And then we have the string there. And then we can see there's another one, which is an event, which is basically just empty. We're not capturing any data in there. It's more of just a empty event. So what I'd like to do is show, well, let's just go ahead and make one. So I'm going to go ahead and use an example from a talk that I did at GraphHack, which is basically, we're just going to create a very basic messaging tool, right, which allows us to send messages. So to do that, we already have Scaffold Leaf up and running here. I went ahead and I just deployed and did a reset. And if you haven't touched any of this stuff, this is basically Scaffold Leaf, which is basically on the left we have the blockchain set up with hard hat. On the top right here we have React, and then on the bottom left is our deploy tool that we're using to deploy, which is using Yarn. So we're deploying our smart contract, which I've already done, and this is our smart contract. It's pretty much empty. There's no smart contract. There's basically nothing in it. So if we pull up Scaffold Leaf and we'll look here, we'll see that it's not loading any functions. It has the contract address and it has a value of 0. But under debug contracts, there's nothing there. So we're just going to add some stuff to it. So let's pretend like we want to create a smart contract that sends messages between each other. So we can do what's called an event. So we can say event send message. And by the way, with events, I think best practice is that you capitalize each, in camel case, each verb or noun or whatever. In this case, we're doing send a message. We're capturing the address, and we're going to call that, we use the variable name of from, so the address of where the message is coming from, and then address to, and then that's who the message is going to go to, and then we're going to get a string, and that one we're going to call message. So those are just the names of the variables and the types of variables that we need to pass into that event. So we define the event, name it, which variables we're taking in, what they're going to be called, and what type of variables they are as well. So usually you can do something like this where you do an underscore if it's an internal variable. That's like common best practice for me. That's what I do. Not required, but. And then we'll create a function that says send message. If you're joining, please go on mute for me. Okay, then we're going to create another function that's called send message, which is going to take in some variables. So we need to do the same thing, and then, but we need to, in this case, we need to also, we only really need to take actually 2 variables, and that's because the from is going to be available in the global variable that we talked about earlier, message.sender. So we don't need to get that one. The 2 we're going to need to take, and the message we're going to need to take. And in this case, we are defining a string And we're using a variable type that is call data, which means it's available in the call data. It's like a cheaper way to get information from the transaction as it goes through the function. So I believe it just uses it at the time of the function being transmitted, or a call is being made, I guess you could say. And I think it's cheaper that way, so I think that's why we're doing it that way, actually. Then we just do an emit, like we showed before, which we're going to reference the event, and we're going to send who it's from. So it's from message.sender. It's to _to, and the message is _message. Okay. And we need to do this like this. Okay, so that should work. Let's go ahead and save that, and then let's go ahead and try to deploy it. It might be a little slow right now. I'm not sure why, but my computer's running a little slow right now. Okay, that worked. So now let's go to the app, and now we have the function there that's available. So we have a send message function. It's going to ask us where we want to send the address to and what we want to say. So we'll send it to the smart contract. We'll grab this address here. So if you've never seen Scaffold ETH before, you should by now, but if you haven't, you have what's called a burner wallet. It's an in-browser wallet. So we have one here. This is the address for that wallet, and we have some funds. And we can connect to like MetaMask if we wanted to, but we're not going to do that. And then this is the contract address. So we're going to send a message from this wallet, the burner wallet, to this smart contract, which is this address. And then we're going to say something like, I don't know, hello world. Hit send. And that's it. We sent a message. So if we were listening on our front end, then we would be able to see that message. So let's see if we can see that message under here. Oh, actually, we're not going to be able to see it because we don't have it set up properly in the UI. But if we were listening, what we could do is just reset the contract, and I could show you out of the box, like when you set the purpose on the very first contract that ever is deployed. That also has an event, and you would be able to see that under subgraph. You'd also be able to see it under example UI, I believe, as well. Yeah, events here. But we're not listening to the proper event, so it's not going to show up. And I'm not going to go through that right now because it's a little out of scope of what we're doing. But it worked. We know it worked because it was successful. We could send another one if we wanted to and just say, I don't know, goodbye. And we know it's successful because here it says transaction sent. It didn't fail. We didn't get an error message. And we got our JSON response here, which has all the complex, basically all the transaction data in it. So that's events. Any questions about that? Check chat real quick here. Okay, cool. Got lots of, okay. Cool, that's good. Okay, so then the other topic that everyone was supposed to work on was this week and last week. It was kind of a weird week because we're in the middle of the week and I'm not going to be available during the rest of the week. So we only covered two things, but it was from last week and this week. And the other one is function modifiers. So I kind of already showed what a function looked like. We have one here, which does sends a message. Well, function modifiers allow you to basically make changes to the way that a function operates or different things. So like we can say, so here are some let's go through this contract real quick. So we have a contract called function modifier, which is we define some variables. We create an address variable. We create a unsigned integer that's public, which is x equals 10. So that it's basically x and the value is 10. We create a boolean, which is true or false, and we call it locked. The default value for that's going to be false because it's not defined. The owner, the default value for this is going to be zeros, all zeros. So we're just basically this one defines a variable. This one actually defines and sets a variable. And this one defines a variable. So there are default values that's covered in the previous topics, but we're not going to get into that. Then we have what's called the constructor. The constructor is only executed at the time that the smart contract is deployed for the very first time, and everything pretty much is not used inside the constructor. So at the very time that we deployed this contract, we would get a owner variable that is set to the message sender, which is the person that actually deployed the smart contract. We cover that again in previous stuff as well, but so I'm not going to go too much into that. And then we have a modifier that basically requires that a particular message sender, which is the person calling this function, or I should say this modifier function, is equal to owner, and if not owner. I showed this example earlier as well. What you can see here is that's different is underscore is a special character only used inside of a function modifier, and it tells Solidity to execute the rest of the code. Okay. So this is only available inside of the function modifier. Modifiers can take inputs. So in this case, we're passing in an address. So the name of the modifier function is called valid address. We're passing in an address. And then we're also doing another require statement. In this one, we're doing the opposite. We're saying like, well, this address that's being passed should not equal 0. So it shouldn't be a empty address, right? It should be a valid address. I'm sorry, is that a question? Yeah, exactly. Shouldn't be empty. Yeah, so like in this case, it should not be 0. So like the default address, again, is like 0x00000000. So this would just require that someone is passing in a valid address that is actually equals to an address. If it was missing enough characters, or if it was a 0, then it wouldn't function. This one allows us to change the owner, so it allows us to take in a variable. It's a public function, which means it's available outside of the smart contract. But what's interesting about this one, and I go over it as well, but it says only owner. So this is where we get into what modifiers really can be used for, is where you can like require that a specific modifier is used inside of that function. So in this case, we're basically setting or requiring that this function or this modifier function is a message sender, and we've defined that in the constructor. And then later on, we're requiring that if someone runs this function, well, guess what? They also need to run this function, and they also need to run this function, and they need to receive this data into this modifier function. So it's a way for you to like run multiple functions inside of one function, but it's kind of like separate that. So if you had a function that did something and you wanted to reuse that functionality, like we do with these two, which this one is the primary reason is for access control, and this one, the primary reason is to make sure it's a valid address, it's not, incorrect, then we could use that on certain functions so that we don't repeat our work and have to put this stuff into each function, right? Read the line. Basically saves us room on our code, and saving room on the code is very important with Solidity because you want to have the smallest file as possible, and you want to use the smallest amount of characters possible for everything you do, because when you deploy a smart contract on the Ethereum virtual machine, you pay based off the size of the contract, first of all, and then you also pay on the processing of the lines as well. So it's kind of like not cat and mouse game, but it's this kind of like game where you have to play where you're just trying to optimize the contract as much as possible. So that's where function modifiers really come in useful. And then here's another example of a no reentry or no reentrancy attack thing, where we require that basically we set a Boolean where we like lock the modifier. So in this case, we require that it's the function modifier is not locked, so that there's no chance that the function can be re-entered somehow, or like paused and like looped through in a way where you could like This comes because there was this kind of like bug in certain functions sometimes where people would be able to like drain the funds with like a withdraw and pull out all the funds given this function called a reentrancy function, I guess, not a function, reentrancy bug, I guess you would say. And so what this is doing is saying, well, before you even run this function the second time, let's make sure that we've locked it, which is what happens here. We locked it, we set it as locked. Then process everything else inside the existing function and then unlock it. So it's kind of like, this is like setting a little like flag that says, all right, well, we're about to do some stuff. Go ahead and do everything that's in that function, but if someone tries to call this function again, this Boolean is already going to show as true, and it's going to fail and basically revert. So it's kind of like a way for you to like put up like a do not disturb sign on the function that you cannot, someone cannot come in there and run this function again until it's complete, right? Hopefully that makes sense. Any questions about that? Yeah, so it means that once it's running, it can't be accessed again until the existing function is completed. But that's actually not the right way to put it. Yeah, I guess that's probably the best way to put it. So like if I'm calling, so what does this function do? Let's look at it again. So it decrements. It's a counter, right? It does a decrement. So it takes in a number called I. Publicly available, but then it always requires that this runs, right? The no reentrancy function, modifier function. So what we do is we take the variable x and we subtract whatever was passed in the function I. So let's say we passed a 1, we know that x is equal to 10, so after this runs, this should x equal to 9, and then we say if I is less than 1, greater than 1, then keep decrementing until it gets all the way to basically to 1, right? So this part of the function here is going to have to complete before, because that's what it's called here. So like no reentrancy is first called. So this first this check is done, right? The require statement. Then locked is set to true. Then we process everything that's here. Once that's complete, then it gets flagged back to false. And then it would be available to be run again, which at that time it would already be equal to 1, so it would never run again technically. So I know it's kind of confusing. This one's a little bit weirder because it's, it's really hard to see it in code, but that's what it's doing. Yeah. It's basically just a way for you to like lock up the current transaction, or I should say the current processing of the function in a safe way to where no one can come in and do something like maliciously pull out the value from that function, right? Because that's really why no reentrancy was created, or I should say no reentrancy was created, is to keep people from like hacking a function essentially and like coming back in and running it multiple times to drain out funds. So this is kind of how you do it. Yeah. If you just Google reentrancy attack, you'll probably get a better explanation than what I just did. But I tried my best. Yeah. Okay. So yeah, that's pretty much all I wanted to go over today. So I'm going to go ahead and stop recording.